If you've ever tried to build anything out of 2x4s or by pipe fitting, you've already run into a couple of the more annoying industry standards and measurements out there. In this video, I want to run through a whole bunch more, explain them a little bit, at least expose you to them so you know what they are when you see them, and then hopefully you can be a little less annoyed than I was when I first ran into them. I should say here that I'm in the US and I'll be sticking to measurements that we use here. There are metric equivalents, of course, for some of these things, but not all that actually do make sense. First on the list is wire gauges. If you didn't know already, the higher the wire gauge number, the thinner the wire. Intuitively, you would think bigger number, bigger wire, but it's the opposite. The reason for this is that when they first started making wires, the gauge number was the number of times they had to pull the copper through a die to stretch it out and make it thinner. So once you know that, it kind of at least makes a little bit of sense, but that's what it is. I give it a 5 out of 10 on the annoyance scale. Second on my list is sheet metal gauge. Pretty much the same story as the wire. The more times they had to run it through the rollers to make it thinner, the higher the gauge number and the thinner the material gets. So bigger number, thinner material, smaller number, thicker material. The other thing that adds a little extra kicker to this one though is that it's also tied to the weight per volume of the sheet metal. So there's a different actual thickness for, say, a 10 gauge cold rolled steel versus aluminum versus stainless steel versus galvanized steel. They're all different thicknesses. So make sure that you pay attention to that. If you have to change a design from one material to the other, your thickness is going to change. So definitely be on the lookout for that. That gets an annoyance level of 7 out of 10 because that's just extra crazy. I bet you thought drill sizes would be an easy one. Nope. There are fractional drill sizes that go down to about a 1/16 of an inch. Then there's numbers that go down to about 3/1000 of an inch. And there's letters that go between about a 1/4 inch and 0.4 inches. So there's a ton of overlap, and in one drill chart, it'll go from fractions to numbers to letters to back and forth. I'll put up a little diagram here showing the mishmash of drill sizes that go from smallest to biggest. It's a headache. You just have to get used to it. It is what it is. I don't have a good explanation for this one. 5 out of 10. One of the more common weird standards that people will run into is pipe sizes. This is a 1/2 inch pipe. It's actually a pipe nipple for some reason in pipes. Anything less than like 6 inches, I think, is called a pipe nipple. 1/2 inch size. And nothing on here is a 1/2 inch. The ID is about 5/8. The OD is about 7/8. Yeah, nothing 1/2 inch. You just have to know that whatever size you're looking for, the pipe you're actually looking for is going to be bigger than that. And then just be sure to look at the tags really closely. This one actually does have an interesting origin story. When they were first starting to make pipes, people all over the country, world, I suppose, that made pipes. And they'd made pipes however they knew how to make pipes, and so they were all different sizes. Eventually, they said, okay, that's crazy. We need to come up with a standard OD, ID, and thread. And at the time, their process for making steels was not very good. And so they had to make their wall thickness really thick to be able to accommodate the pressures and things that they wanted to run. So originally, the ID was 1/2 inch on a 1/2 inch pipe because they needed the thick wall. Then at some point, they got better at making steels. They could make the walls thinner, but the OD and the pipe threads were already the size that they were. And so that they didn't have to make everybody replace all their pipes and all their fittings or have weird adapters, they kept the OD and the outside dimensions of the pipe the same and made the wall thinner, so the OD got bigger. So originally, it did make sense. 1/2 inch pipe had a 1/2 inch ID, but now since we can make the walls thinner, it's bigger, and we're kind of stuck with it. This one I think is more annoying because your average homeowner is going to run into it at some point. You have to replace a pipe or run a sprinkler line or something. So it's not something that just engineers or people that are, specifically trained in certain areas are going to run into it. So I think this one gets an 8 out of 10 because that's going to trip up a lot of people. The durometer of material describes how hard it is. It's usually used for like rubbers and silicones and plastics and things like that. Not for metals, there's a whole other hardness scale for that. But things that are generally soft, polymers and things like that, you describe the hardness as a durometer. The thing that gets weird though is that you can't really measure things that are super soft the same way you measure things like a hard hat. Right? You need different pressures and different shapes of tools to go in and deform the material a certain amount just to be able to make it a measurable measurement. So they came up with different scales. So for really soft things, there's one scale, kind of medium hardness, and so on and so on. The name for these different scales of hardness is called a shore hardness. So there's shore A and shore B. Those are the kind of different ranges of hardness, which makes sense other than there's a ton of overlap in the middle of all of these different scales. So something like a car tire is Shore 0097, but it's also a Shore A70, and it's also a Shore D15. Usually vendors will only offer, obviously, a certain material as a certain Shore, even though it apparently matches the same hardness in another Shore. I don't know how they decide what, but it's just what it is. This one gets a 7 out of 10 for me because nothing drives me more crazy than having two specs that could define the same thing. That just drives me nuts. When I saw how car tire sizes were spec'd, my head nearly exploded. I'm going to explain it here. It makes literally no sense. I dare anybody to explain it to me in a way that makes sense. So here we go. So say we have a car tire. It's a 225, 45, R19. Let's start at the beginning. 225. That is the tire tread width in millimeters. Fine. Millimeters, a little odd for an American style measurement, but whatever. Here's where things really go off the rails. The 45. Is that the measurement of the sidewall? Some other actual measurement on the tire? No. It's the ratio of the sidewall height to the tire width. Who thought that was a good idea? So we've got millimeters and basically a percentage or a ratio so far. Finally, to the R19. Is that a radius of 19? No, that doesn't make any sense. The R is the tire construction type, radial, biased. Okay, that kind of makes sense. That information needs to be in there. And the 19 is the wheel diameter in inches. Not the outside of the wheel, but the bead diameter, so you can't even actually measure it from the outside. Anybody, please make that make sense. So in the spec for a tire, you have inches, a ratio, and millimeters. And now we circle all the way back to 2x4s, dimensional lumber. A 2x4 is actually 1.5 by 2.5. Half an inch off in either direction. Doesn't make any sense, right? And 4x4s are just as far off, and 2x6s and 2x8s. A lot of people say that the lumber mills cut it to actual size, and then over time, as the moisture leaves it and it dries out, it shrinks down to that final size. But that's not true. It wouldn't make any sense for a 2x4 to shrink a half inch, both in length and width anyway, and that would be a ton of shrinkage. So that's not the case. The real answer is a lot more annoying. In the beginning, a 2x4 was 2 inches by 4 inches. Then people started to have to ship lumber across the country and pay shipping charges. And they said, what if a 2x4 could actually be smaller than a 2x4 and I could still ship 100 of them, but it would cost me less in freight? When that started to get out of hand, there was decades of bickering between lumber mills and railroads and government trying to figure out a standard that everybody was happy with. And this is where we ended up, where these measurements are the standard. Everybody knows what they're going to get. It's not what they're called. It's super annoying. You just have to know. Annoying level, 8 out of 10. So that's my list of annoying industry standards and measurements. If you have others that I didn't think of, feel free to leave them in the comments. I'd like to hear about it. If you have another description of how any of these came about, let me know. It'd be interesting to see if there's some other stories going around out there. Again, I hope it helped, and I'll see you next time. Bye. Testing. No, nope. Dang dogs. Can be a little. The OD is closer to. I should know that.